Scientific notation is shorthand for scientists. It is too cumbersome to write lots of zeros in front of or behind numbers. Unfortunately, how much the number really represents is often lost on people. The following is an excerpt from Bill Bryson's book, A Short History of Nearly Everything. The Big Bang Theory isn't about the bang itself, but about what happened after the bang. Not long after, mind you. By doing a lot of math and watching carefully what goes on in particle accelerators, scientists believe they can look back to 10 to the negative 43rd seconds after the moment of creation, when the universe was still so small that you would have needed a microscope to find it. We mustn't swoon over every extraordinary number that comes before us, but it is perhaps worth latching on to one from time to time, just to be reminded of their ungraspable and amazing breadth. Thus, 10 to the negative 43rd is 0.0000000000000000000000000000001, or 1/10,000,000,000,000,000,000,000ths of a second. He later goes on to write, though I salute the principle, scientific notation, it remains an amazement to me that anyone seeing 1.4 times 10 to the 9th kilometers cubed would see at once that that signifies 1.4 billion cubic kilometers. Very often we get caught up in numbers and decimal places and truly lose how much these numbers actually stand for, how small atoms really are, and how many make up your being. With that in mind, always keep a good perspective with numbers and constantly ask yourself when doing calculations, does my answer make sense? Okay, so now I'd like you to see how well you understand how this scientific notation works. Take the following numbers and put them on the number line on your worksheet. Pause the video, guess, and then check your numbers. If the numbers are the same, then put them in the same spot on the number line. Your answers should have been what you see on the screen. Notice how the negative in the exponent only signifies that the number is less than 1, not 0. Also, I added 10 to the 0th power at 1 because anything to the 0th power is 1. Notice how 10 to the 1st and 10 are the same. So we're talking about like 1. So we're talking about like 1 times 10 to the 1st. And 10 to the 2nd is not 200, it's 100. So we're talking about 1 times 10 to the 2nd. And then again, like I said, notice how negative exponents just mean that the number is less than 1. The only number less than 0 is a negative 1. Or negative 2 or something along that line. So let's look at standard notation and what that means. This is the notation where the number is written out. Like if I were to write out 1 with 6 zeros, or if I were to write 1 with 6 zeros the other way. That's a standard notation. The numbers are written out longhand. If you're looking at scientific notation, so these are based on powers of 10. Where you have 10 to the 1st. This is going to be 10 times 1. You have 10 to the 2nd, which is 10 times 10. 10 to the 3rd, which is 10 times 10 times 10. And so on. The numbers are written out with something times 10 to the something else, as clear as that sounds. The number out in front must be between 1 and 9. Can't be a 0, can't be a 10. The exponent denotes how many places the decimal is moved. So whether we're going to move the decimal 2 places, 3 places, 4, negative 1 places, or places to the left. For numbers greater than 1, the exponent is going to be positive. For numbers less than 1, then the exponent is going to be negative. So it'll be this guy. So a number greater than 1 might be 2 times 10 to the second. Or a number less than 1 will be 2 times 10 to the negative second. Take a moment then and convert the following numbers either to scientific notation or from scientific notation. Pause the video and try converting them first and then check your answers. Here are the answers. As you can see, the exponents that are less than 1 were decimal numbers, so like letter B there and letter A. And the decimal is moved the number of spaces based on the exponent. So on the right side over here, we had to move it 4 places. So I moved it 1, 2, 3, 4. Okay? And letter E, I moved it 3 places to the left. So you start here and go 1, 2, 3. Notice how it doesn't matter whether it's a positive number, like an E, or whether it's a negative number, like an F. You just get a negative out in front. The larger the exponent, the larger the number. Since scientific notation is shorthand of the numbers, you need to be careful when performing math operations. When adding or subtracting numbers, the exponents must be the same. Take, for example, 1,300 plus 14,200. Well, the answer is just going to be 15,500. When this is written out in scientific notation, though, it looks a little bit differently. It looks like 1.3 times 10 to the third plus 1.42 times 10 to the fourth. Well, if you're thinking when you're just going to add those, you might just straight add them and get 2.72 times 10 to the seventh. Well, that's not how that works. These obviously are not the same answer or even close. So you got to be careful when you add numbers in scientific notation. They need to have the same exponent. It's usually easier to convert them both to the larger exponent, but you can also do it the other way. So what would happen then is this guy would change, and I'm going to make him times 10 to the fourth. Well, that means I'm going to have to go one more place to the right when I go through and draw them out. So I need to make it 0.13 because that still means I'm going to move this 4 places, which will still be the same number. So I add the decimal here, and I'm moving at 1, 2, 3, 4. Still the same number. This really isn't correct scientific notation, so you wouldn't want an answer like this, but to add them without a calculator is what you would do. So I take that plus 1.42 times 10 to the fourth, and now we're going to get our right answer. We just straight add the coefficients here, and I'm going to get 1.55 times 10 to the fourth, which is the same exact number as what I got when I had it written out long ways. When multiplying or dividing, your exponents do not need to change. So you don't have to change them to be the exact same exponent. The exponents are added together when your coefficients are multiplied, and your exponents are subtracted when the coefficients are divided. So when you multiply the coefficients, or those numbers out in front, and you add the exponents. When you divide your coefficients, and you subtract your exponents. And the only thing you have to be careful with here is that if you get an answer that's no longer in correct scientific notation, you're going to have to switch it. So for example, if I get an answer when I multiply to be 12 times 10 to the fifth, I can't leave it like that. This number here needs to be between 1 and 9. So I'd have to switch it from 12 times 10 to the fifth to being 1.2 times 10. This is always the question, do I make it 4 or do I make it 6? Well, I'm going to have to go one more place to make it 12 times 10 to the fifth. So that means I'm going to have to make it 1.2 times 10 to the sixth. So you have to be careful and make sure your answer is in correct scientific notation. Now go ahead and try the examples on the back of the page here. Pause after trying one, check your answer, and then also remember the order of operations. Do not use a calculator.